Okay, so concept number 1 is all about sequences, and our objective for this concept is I can find the nth term of a sequence. I'm trying to write so my hand's not in the way, and write rules for sequences. So there's two things we're going to be doing in this section. Okay, so I can find the nth term of a sequence and write rules for sequences, which rule is really just like equation. So we're going to be writing equations for sequences. Okay, so first of all, what is a sequence? Well, a sequence is a set of numbers. I'm just going to use the pound sign. Set of numbers with a particular order. Particular order or pattern. Okay, each number is called a term. So when I talk about terms of a sequence, I mean the numbers in the sequence. Okay. Finite sequences is exactly what it sounds like. It's a sequence with a limited number of terms. Okay, so here's an example of a finite sequence. 1, 2, 3, 4, 5. It ends right at 5. It doesn't keep going on and on forever. Okay, so that's a finite sequence. An infinite sequence is a sequence with an unlimited number of terms. So a sequence, that's a Q, with, oh my gosh, I cannot write today, with an unlimited number of terms. So these kinds of sequences go on and on forever until infinity. Okay, that's what an infinite sequence is. So here's an example. 0, 1, 2, 3, 4, 5, comma, dot, dot, dot. Here's how you know that it's infinite. If there's an ellipses, this is called an ellipses, which signifies to you that it keeps going on and on forever. Okay, so in this example, this is the set of all the whole numbers. Whole numbers. Okay. Whole numbers go on and on forever. They don't stop. All right, so those are the types of sequences there are. There's either a finite, which means there's a limited, or an infinite, which means there's an unlimited. Makes sense. So term notation. So the first term in a sequence is denoted A sub 1. So I'm going to write that down. A sub 1. It's not A1, it's A sub 1. We say sub 1 because the 1 is smaller than the A. It's a little subscript, okay? So A sub 1 is the first term. Each subsequent term is denoted A sub n. Okay, so I'm going to write that down. This is A sub n. Okay, not an, not an, A sub n, where n is the term number in the sequence. So if it's the first term, it's A sub 1. If it's the second term, it's A sub 2. Third, A sub 3, so on and so forth. Okay? So here's an example. Given 1, 5, 9, 13, 17, on and on, this is an infinite sequence. Identify the following term values. A sub 1. What is the very first term? Okay, so fourth term, what's the fourth term? 1, 2, 3, 4, 13. Okay, A sub 9, we need to figure out the ninth term. So to do that, we need to figure out, well, what's the pattern? Okay, so, well, this is going up by 4, up by 4, up by 4, up by 4. So we just need to figure out what are they? So 1, 2, 3, 4, 5. If we keep going, 17 plus 4 is 21. That's the sixth term. 25 is the seventh term. 29 is the eighth term. So I'm just adding 4 every single time. So 29 plus 4 is 33. So that's the ninth term. Okay. the 12th term, if we keep going on and on, so 33, so this is 9 plus 4 is 37, 10 plus 4 is 41, plus 4 again is 45. So let's see, we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 45 is our 12th term. So really you're just figuring out the pattern and then you're finding the number that matches. Okay? So now let's talk about sequences as functions, because really they are functions. The term number is your input, so 1, 2, 3, 4, 5, 6, 7, 8, 9. And then the actual term is your output. So in this case, our term number is 1, 2, 3, 4, 5, 6, all on and on. Our output is the actual term themselves, so 1, 5, 9, 13, 17. Okay? So we're going to figure out how to figure out, gosh, I sound like figure out how to figure out, oh my gosh. Let's just keep going. Since each term value is paired with exactly one term number, just like I said, a sequence is a function with the following properties. The domain is the set of term numbers. Domain input, okay? Again, I'm just repeating myself over and over and over again. The range output, so you can write input, output, is the set of term values. Okay? Input, output. Hey, look, it's the same sequence. Interesting. In an infinite set, the domain is the set of natural numbers, which means they're the counting numbers. Okay, so it's not negatives, it's not 0, it's positives, 1, 2, 3, 4, whole numbers. Okay. All right. So in the next video, I'll talk a little bit about recursive formulas and how we can use them to figure out sequences.